Welcome to Sir JC's Math Class. This is brought to you by Matsaya TV. Hello grade 8 students! Are you ready for the next level math? Our topic for today is factoring polynomials by common monomial factor. Let's begin! Here are the objectives for this lesson. Find the greatest common factor or GCF by listing or prime factorization. Factor polynomials completely with common monomial factor, and use distributive property to factor polynomials. In order for us to fully understand the lesson, let's discuss the meaning of these words. Greatest common factor. This is the greatest number that is a factor of two or more other numbers. Factors are numbers that can be multiplied to get another number. Example, factors of 12 are 1, 2, 3, 4, 6, 12. And factors of 16 are 1, 2, 4, 8, 16. Take note that three of their factors are the same or common, namely 1, 2, and 4. But which is the highest? That's right, 4 is the greatest common factor of 12 and 16. Prime factors. Factors that are prime numbers. Take note that prime numbers are numbers that can only be made from multiplying 1 and the prime number itself. Example, 2 and 3 are factors of 6 because we can multiply 2 times 3 to get 6. At the same time, 2 and 3 are prime numbers because you can only get 2 and 3 by multiplying 1 times 2 and 1 times 3. Therefore, 2 and 3 are prime factors of 6. Polynomial. Polynomial comes from the poly, meaning many, and nomial, in this case, meaning term. So it says many terms. A polynomial can have constants, variable, and exponents that can be combined by addition, subtraction, multiplication, division. However, there are exceptions. The terms cannot be divided by a variable, and the exponents of the variables can only be whole numbers. In our example, the polynomial 4xy squared plus 3x minus 5 consists of three terms, namely 4xy squared, 3x, and 5 or negative 5. Monomial, a polynomial with just one term. In this example, we have the monomial 3xy squared. Standard form. The standard form for writing a polynomial is to put the terms with the highest degree first, like the 2 in x squared if there is one variable. Example, we need to write this polynomial in standard form. We have 3x squared minus 7 plus 4x cubed plus x raised to 6 power. The highest degree is 6, so that goes first. Then 3, 2, and then the constant last. We will have x to the 6th power plus 4x cubed plus 3x squared minus 7. Great! Can you repeat the different words that we unlocked? They are greatest common factor, prime factors, polynomial, monomial, and standard form. Let's continue! It's activity time! Oh no! We are on lockdown! In order for us to get free, we need to match the keys to its corresponding lock by expressing each number or term using its prime factors. If you can do it on your own, you may pause this video and write your answer on a sheet of paper. Let's start with 12. Can you express 12 as a product of two factors? If you answered 4 times 3, you are correct. However, is 4 a prime factor? No. That's why we need to express 4 as a product of prime factors, which will give us 2 times 2. We can notice that the prime factors of 12 are 2 and 2 and 3. We can express it using exponents like this. 2 squared times 3. Let's see if this key is correct. Great job! 30. If you express 30 as 2 times 15, your answer is correct. But is 15 a prime number? No, That's why we will express 15 as 3 times 5, which is its prime factors. This will give us 2, 3, and 5, which are the prime factors of 30. Therefore, 30 can be expressed as 2 times 3 times 5. Let's see if this key is correct. Nice! This time, let's have some variables. 3x squared y. First, let's separate the constant and variables. We can notice that 3 is a prime factor, but x squared y is a product of variables x and y. This means that we can express it as a product of its factors x squared and y. This will give us 3, x squared, and y as the prime factors of 3x squared y. We will express it like this. Let's see if this key is correct. Keep it up! For our last question, we have 15a cubed. Can you separate the constant and variable? That's great! This will give us 15 and a cubed. 15 is a composite number. Therefore, we can still express it as a product of two numbers. This will give us 3 and 5, which are prime factors of 15. Using the prime factors 3, 5, and a cubed, 15a cubed can be expressed like this. Let's see if this key is correct. You are doing great! Great job, everyone! We have unlocked all of them. But remember, if it's still not completely safe outside, then stay at home as much as possible. Stay safe and healthy! Let's start our lesson. Greatest common factor. In polynomials, this refers to the common factor having the greatest numerical factor and with the variables having the least degree. Let's have some example. 6x squared and 15x to the 4th power. First, we will express 6x squared using its prime factors. Following what we did in our activity a while ago, this will give us 2 times 3 times x squared. Then, we will express 15x to the 4th as 3 times 5 times x to the 4th. Notice that 3 is their greatest numerical common factor, while 2 is the lowest degree of the variable x. This will give us the greatest common factor or GCF, which is 3x squared. That's it. Let's have some examples. Find the GCF of each pair of monomials. If you can do it on your own, you may pause the video first and answer. Then listen carefully to my explanation. Number 1. 6a and 18ab. First, let's express the monomials using prime factors. 6a will become 2 times 3 times a. 18ab will become 2 times 3 times 3 times a times b. Can you point out the common numerical factors? Yes, 2 and 3 are the common numerical factors of 6 and 18. 2 times 3 will give their greatest numerical common factor. How about the least degree of the variable? Take note that only a is the common variable and 1 is its degree on both monomials, which is also the lowest degree. This will complete our GCF, which is 2 times 3 times a. Simplifying, our final answer is 6a. I hope it's clear. Number 2. 10a and 12a squared b. Let's express the two monomials using prime factors. 10a will become 2 times 5 times a, while 12a squared b will become 2 times 2 times 3 times a squared times b. The common numerical factor is 2. But Sir JC, there are two 2's in the prime factors of 12. Why we only get 1? Let me clarify that when we are getting the common numerical factor, the factors are treated separately. Since there is only one 2 in the factor of 10, we will also get only one 2 in the factors of 12 because the two of them makes a pair. As they say, life is better when we form correct pairs. Going back to our example, a is the only common variable and 1 is the lowest degree. This will give us the GCF, which is 2 times a, or simply 2a. Great job! Here are other examples. Let's answer them in detail. Number 3, negative 8x squared y and 16xy. Expressing these two monomials using prime factors, we will have negative 8x squared y as negative 2 times 2 times 2 times x squared times y. Take note that the negative sign is written outside of the 2. 16xy as 2 times 2 times 2 times 2 times x times y. What can you notice? That's correct. We can get 3 counts of 2 in each of our monomials. We will get this as part of our GCF. In our variables, x and y are both common, but the lowest degree for x is 1, while the degree of y is both 1. We will get x times y for our GCF. This will give us 2 times 2 times 2 times x times y. Simplifying it, our GCF is 8xy. Number 4, 8ab cubed and 10a squared b squared. Please follow my explanation carefully. 8ab cubed is expressed as 2 times 2 times 2 times a times b cubed, while 10a squared b squared is expressed as 2 times 5 times a squared times b squared. Notice that 2 is our only common factor. A is common variable and its lowest degree is 1. And b is also a common variable and its lowest degree is 2. We will get this to form our GCF, which is 2 times a times b squared, or simply 2ab squared. Can you still follow? That's great! Remember, you may rewatch some parts of this video if you miss out anything. This time, let's factor polynomials. When we are factoring polynomial, this means rewriting a polynomial as a product of polynomials of smaller degree. To explain it more clearly, let's have this table: polynomial, GCF, and the factored form of the polynomial. Example number 1, 4x squared plus 6x. Can you give the GCF of 4x squared and 6x? Yes, that's 2x. Now, we will use the reverse of distributive property to get the factored form of the polynomial. Let's have a review of your grade 7 math. Here is an example of using distributive property. We have 4 times quantity x plus 3. Using distributive property, we will distribute 4 by multiplying it on each of the terms inside the parentheses. We will have 4 times x plus 4 times 3, or 4x plus 12. That is using distributive property. This time, we will do the reverse. Using 2x as our GCF, the factored form of our polynomial is 2x times quantity 2x plus 3. To check, we can multiply 2x times 2x equals 4x squared, and 2x times 3 equals 6x. 4x squared plus 6x is our polynomial, which means our answer is correct. Another example, 3x squared plus 6x. The GCF is 3x. Using GCF and distributive property, we can express it as 3x times quantity x plus 2. Let's check. 3x times x is 3x squared. And 3x times 2 is 6x. This means our answer is correct. Good job! 6x to the 4th minus 14x squared. Can you give the GCF? Yes, the GCF is 2x squared. Now, can you use the GCF and distributive property to express the polynomial in factored form? The factored form is 2x squared times quantity 3x squared minus 7. Let's check. 2x squared times 3x squared is 6x to the 4th power. And 2x squared times negative 7 is negative 14x squared. 6x to the 4th power minus 14x squared is our polynomial, which means the factored form is correct. Nice! Is it clear? Don't worry, let's have some more examples and I will show you another way of doing it. Let's have a detailed explanation of these examples. 8x squared plus 12x. First step, use GCF to rewrite the polynomial. The GCF of 8x squared and 12x is 4x. We can express 8x squared as 4x times 2x, while 12x as 4x times 3. Then, we will factor out the GCF by using distributive property. We will have 4x times quantity 2x plus 3. Take note of the signs and the placement of the terms. Another example, 9y squared plus 18y. Can you give the GCF of 9y squared and 18y? If your answer is 9y, you are correct. We will use the GCF to rewrite the polynomial. This will become 9y times y plus 9y times 2. Using distributive property, factor out 9y and our polynomial will become 9y times quantity y plus 2. There you have it! I hope it is clearer now. Here are other examples. Let's start. 6x to the 4th minus 14x squared. First step, use its GCF to rewrite the polynomial. This will become 2x squared times 3x squared minus 2x squared times 7. Then factor out 2x squared using distributive property. Our answer will become 2x squared times quantity 3x squared minus 7. Take note that the minus sign was carried over inside the quantity and not with 2x squared. Next, we have 7a times quantity a plus 3 minus c times quantity a plus 3. Notice that this polynomial is already expressed using GCF. So we will proceed to the next step. Factor out GCF, which is a plus 3. We will have quantity a plus 3 times quantity 7a minus c. Take note that the minus sign was carried over by c. Last example, 8m times quantity n plus 3 plus p times quantity n plus 3. Again, this example is already expressed in factored form. Using GCF and distributive property, we will have quantity n plus 3 times quantity 8m plus p. You are doing great! Keep it up! Let's try a challenging one. Take a look at this. Are you ready? Let's do this! We have 4 times quantity 3b minus 1 plus 5a times quantity 1 minus 3b plus 4c times quantity 3b minus 1. Can you notice anything? Yes, it looks like it is expressed already by its GCF. However, take note that we have 5a times quantity 1 minus 3b, which is different from the other two terms, which one of the factors is 3b minus 1. Therefore, we need to rewrite 1 minus 3b to make it similar with the others. First, rewrite 1 minus 3b as negative 3b plus 1. We did this by applying the commutative property. Please take note of the signs. Then, we will factor out negative 1 from negative 3b plus 1 and multiply it to 5a. This will give us 4 times quantity 3b minus 1 minus 5a times quantity 3b minus 1 plus 4c times quantity 3b minus 1. Take note of the sign when we multiplied 5a by negative 1. We can now notice that the polynomial inside the parentheses are common. Therefore, we can factor it out. We can factor out 3b minus 1, then we get the other factors of each term, 4 minus 5a plus 4c. So the final answer is quantity 3b minus 1 times quantity 4 minus 5a plus 4c. Nice work! Thank you for accepting the challenge. It's time for an exercise! Factor each polynomial by using GCF and distributive property. You may pause this video and write your step-by-step solution and final answers on a sheet of paper. Good luck! Let's have the solutions and answers. 8a cubed minus 10a squared. First step, using the GCF, which is 2a squared, we can rewrite the polynomial as 2a squared times 4a minus 2a squared times 5. Then, we will factor out the GCF using distributive property. Our final answer is 2a squared times quantity 4a minus 5. If your answer is this, you are correct. 6 times quantity 2c squared minus 3 minus a times quantity 6 minus 4c squared. First step, we will rewrite 6 minus 4c squared as negative 4c squared plus 6. This will give us 6 times quantity 2c squared minus 3 minus a times quantity negative 4c squared plus 6. Then, to have common factors, we will factor out negative 2 from negative 4c squared plus 6 to make it common with 2c squared minus 3. Simplifying this step, we will have 6 times quantity 2c squared minus 3 plus 2a because negative a times negative 2 is positive 2a times quantity 2c squared minus 3. Factoring out the GCF, our final answer is quantity 6 plus 2a times quantity 2c squared minus 3. If this is your answer, correct! That's it for today's lesson. I hope you will wait for the next one. Together, we can learn math. Thank you for watching! To keep you updated on our next videos, don't forget to subscribe and hit the notification bell. See ya!